Good day, class. So, our topic is about scientific notation. So, let us define first the meaning of scientific notation. So, here it is a method of writing very small or very large numbers into manageable length so that we can easily compare it with other numbers and illustrate it. Okay, so we have here the form a times 10 raised to n, where our a is greater than or equal to 1 but less than 10. And our n here should be an element of an integer. So take note that scientific notation is based on the powers of 10. Okay, for example, we have the scientific notation of 8 million, that is 8 times 10 raised to 6. So as you can see, it's based on the powers of 10. Later on, you would know how to convert this standard form into scientific notation. Okay, so before we convert a class, let us know first the meaning of coefficient or our A. Remember, we have this form A, so what does it mean with this A? So in scientific notation, it is the number multiplied to the power of 10. Okay, its absolute value should be greater than or equal to 1 but less than 10. Okay, so that was our condition earlier, that it should be greater than or equal to 1 but less than 10. Okay, so again, that is called our coefficient. So in this example, the scientific notation of 6 times 10 raised to 7, okay, our coefficient here is the 6. Also, we have what we call base. Base is the fixed value 10 in a scientific notation. Okay, so for example, in the scientific notation, 2 times 10 raised to 9, the base 10 is raised to the ninth power. Okay, so again, that is the fixed value, which is 10. That is our base. Lastly, for the exponent, we discussed this last time, but for the exponent in scientific notation, it is the exponent of the base, which should be an integer. Okay, meaning to say it can be a negative natural number, 0, or a positive natural number. Okay, examples are the following. In 4 times 10 raised to negative 6, the exponent is negative 6. It's a negative integer. Okay, however, the expression 4 times 10 raised to 1 half is not considered a scientific notation since the exponent of 10 is not an integer. Okay, so make sure that the exponent is an element of an integer. Okay, so since we know already what coefficients, base, and exponents are, I think we are ready to convert standard form to scientific notation. Okay, so in converting standard form to scientific notation, we have two cases. The first case, if non-zero comes first and the decimal point comes next, we move the decimal point to the left and our n or our integer should be a positive integer. Okay, so for instance, okay, so here the non-zero comes first. For instance, we have 4,500. As you can see, the non-zero comes first and the decimal point comes next. So our decimal point here is after the 4,500 since it's a whole number. Okay? Therefore, to find its scientific notation or to convert this one, we should move the decimal point to the left side of our given. Okay? Making sure that our 4 here is the last digit. Okay, so and our n should be a positive integer, meaning to say our exponent should be an integer. So to write that, it would be 4 0.5, okay, times 10 raised to 3. Alright. In our case 2, if the decimal point rather comes first and non-zero comes next, we have to move the decimal point to the right, okay? And our n, or our exponent, should be a negative integer. In this case, if we have 0.000045, okay, as you can see here, we have the decimal point first before the non-zero, which are 4 and 5. So we should move the decimal point to the right, okay, making sure that it stops on the last digit. So 1, 2, 3, 4. Okay, so here it can be also written as 4.5 times 10, the number of times we move places, 4, and it should be negative. So it should be written as like this. Okay, so for more examples, for the case 1, we have to write 4,500,000 in scientific notation. Okay, so here we have to move the decimal point to the left until it is directly to the right of the first non-zero, which is 4. Okay, so since this is a whole number, our decimal point is in here on the right. That's why we have to move to the left, okay, until we come to the right of the first non-zero. So 1, 2, 3, 4, 5, 6. Alright. Okay. So it follows that our A, or our coefficient, would be 4.5. Okay. Since the decimal point was moved to the left, the exponent should be positive. Thus, our n, or our exponent, are the number of places we moved, okay? And that is 6. So if we count that, 1, 2, 3, 4, 5, 6. Okay. Hence, the given number, or the given standard form, can be written as 4.5 times 10 raised to 6 in scientific notation. Okay, so as you can see here, instead of writing 4,500,000, we can just write it in a form of 4.5 times 10 raised to 6. For example, for case 2, if we express 0.000068 in scientific notation, okay, this time, as you can see, the decimal point comes first before the non-zero. Therefore, we have to move to the right, okay, until there is one digit on the left of the decimal point. So moving this to the right, 1, 2, 3, 4, 5, okay, we have already the coefficient 6.8, okay. Remember how many times we moved, because that would be our exponent. Okay, so since the decimal point was moved to the right, the exponent should be negative. Okay, thus our exponent n is negative 5, the number of times we moved the decimal point earlier. Okay, hence the given number can be written as 6.8 times 10 raised to negative 5 in scientific notation. So this is how we write it. Okay, now let's do the vice versa. How do we now convert scientific notation to standard form? Here we also have two cases. The first case, if we have positive exponents of 10, we have to move the decimal point to the right, okay? And of course, the exponent tells us how many decimal places we have to move, okay? For the case 2, it's just the opposite of this. For negative exponents of 10, we have to move the decimal point to the left, okay? So meaning to say, we're just doing vice versa. Okay, if we can convert from scientific to standard, okay, we can also go back to to standard to scientific notation. Okay, so let's have an example. So as you can see here, the exponent is positive, which is 4. Therefore, we should move to the right. So it's very easy to remember. Okay, if we have a number line, okay, if it's positive, it's on the right. So we should move to the right. Okay. Hence, if we have here 2.8, moving 4 places, since our exponent is 4, to the right, that would be 1, 2, 3, 4. Okay, and here is our decimal point. Just fill in the places with zeros. Okay, that's why our answer is 28,000. Okay, how about for the example on case 2? Here, as you can see, the exponent is negative, so we should move to the left. Okay, so sorry about this, it should be 1.17 is our given. Okay, so moving that to the left side, okay, since this is negative, it would be, so 1.17, it would be 1, 2, 3, 4, 5. Okay, so we fill in zeros to the spaces. Okay, hence our answer is, it should be 0.000117. Okay, so for your assignment, answer what is asked and upload your answers on the LMS. So that's it. We have 10 items. Thank you for listening.